Okay, once again, allow me to welcome you. It has been a long time ever since we posted last video, so we are here back again. So you're going to look at the activities of integration for all senior 1 topics. They are 14 in total, and let's see. So please, we kindly call for your subscription, subscribe, like, share, and comment, please, such that content of this kind always comes your way. By just subscribing, we can be able to move. Okay, so now what you're going to look at here are the activities of integration of senior 1. So of recent, there is some document which circulated on the social media. Actually, that's WhatsApp, and some people came in my inbox. Actually, over 100 people almost were coming into my inbox to at least look into that, and here we are. And so far we have started with senior 1. Next will be senior 2, senior 3, and senior 4. So I'd want to send these regards to whoever compiled these activities of integration. Please, what I'm doing here is only providing answers to what they had put in that document. Okay, personally, I don't know whether the answers are there already, but I tried to sit down with our board and we looked into what the solutions were meant to be. Okay, so and with that, I want to send my appreciations to teacher Wilbur for compiling this wonderful work. Okay, and I think let's start off with the topic 1. Topic 1 in our syllabus is number bases, and this is always for senior 1. Now let's start. We have item 1. Now this is an activity of integration. Please, these activities of integrations can be generated from, they can be generated from or got for after the end of the chapter. And of course, where should we always set the activities of integrations from? We have what we call learning outcomes, and you can get that based in the syllabus book. Every topic has got what we call a learning outcome. So when you get the learning outcome, you can easily see. Now, like in this, among the learning outcomes of number bases, one of them is a student must be able to convert from one base to another, and of course we shall be seeing that. And I think the people who said this activity of integration also looked into that. So that's what we simply do. Please, the activities of integration come from the learning outcomes, and much as we have very many learning outcomes, it implies that you may set more than one activity of integration for any topic, though some people were taking it that the ones we have in the students book and teachers guides, they are the ones we should always consider. No, please, the creativity matters. You can as well create yours, so long as it really matches with the learning outcomes and as per the syllabus book. I think let's start off with number 1 without wasting time. Okay, it says the member of Mukuji village circle are in dilemma. They need to withdraw money. Let me get the ink pen here. Okay, the members of Mukuju village circle are in dilemma. They need to withdraw money from their circle account for an opportunity function. The circle chairman, trying to protect the 4-digit PIN of the ATM card, converted each digit from base 10 into other base lower than base 5. In fact, we need to note this down. Okay, let's note this down. Okay, so let's try to be underlining. So a 4-digit ATM pin, okay, converted into base 10 into another base lower than base 5. Okay, the converted pin is recorded as, so this is the corrected converted pin. Now take note, these are 4 digits. It means that this 13 is for 1 digit, this 20, not 20 but 20, this 20 is for a certain digit, this 21 is for a certain digit, this 12 is also for a certain digit. So all these digits here have different, they are different. So I said that this is 1, this is 1, this is 2, this is 3, and this is 4. So you see them as 2 digits, but they mean 1 digit. If that is if we put everything in base. Okay, 10. Okay, unfortunately, the chairman cannot remember the exact base he used for conversion. Now here they say the base is lower than 5, meaning that you can think about base 4, base 3, base 2. Okay, so I don't remember the exact base he used for conversion, leaving the circle members unable to withdraw the funds. Okay, in the task they said, with the reason, help the circle members identify the base and the original pin so they can withdraw the money. Now here, the situation was, what you should know is that as far as number bases are concerned, everything we count in real life, everything we do, our age, our weight, okay, when you're counting, say for example, the mangoes, the money you have is always in base 10. So anything we use in real life in counting is always in base 10. But here these people went a bit fun and they converted to a base less than 4, less than 5, and that is base 4, base 3, and base 2. Now here you must know which base specifically contains this kind of digits. You must be knowing which base specifically contains this kind of digits. Okay, which base specifically contains this, by the way? Let's see. Which base contains this? Which base contains this? Which base contains this? Okay, and which base also contains that? You look at the digits. Okay, let's now go and see. Let's go into the solutions and we see. So in simple terms, these digits here are either in base 2, base 4, because the base less than 5, you can think about base 4, base 3, base 2. Please, the base 1 is not all that common, so we're not going to it. So base 4, base 3, and base 2. Now let's see, what did they use? And when you look at the digits here, you look at the highest value here is 3, and we know that in base 3 we don't have 3. So therefore, this implies that these values were converted strictly to base, okay, base either. Now in base 3 we don't have 3, so now in base 2 we don't have 3, you cancel. So in base 3 we don't have 3, so definitely what remains is base what? 4. So it means that these people converted to base 4, as you can see. So now let's see. Now they're asking, in fact, let's go back here. They're asking with the reason, help the circle members identify the base. Now the reason is, tell them first of all which base. Remember they were confused about which base did the chairman convert the pin to. So the reason must be the base and why that base. Let's start with that. Let's go and see. Okay, let's start with that. So you realize that they're saying the chairman converted the pin to base 4. Now why base 4? Because base 4 has digits like 0, 1, 2, and 3. So please, you all know that in any base we don't have a digit more than that very base. So it means that if you have base, say for example base 2 has digits like 0, 1, and 2. That's what we have in base what? That's what we have in base 3, rather base 2. Now base 3 has digits like 0, 1, 2. Now we don't have 2 in the base. Sorry, about base 2 we don't have 2. By the way, let me repeat this. In the base 2 we don't have 2. In the base 2 we don't have 2 there, erase of this. So in the base 2 we don't have 2. So in the bases once you have 2, it will start from 0, 1. So in the base 2 you have 2 digits, 0 and 1. Then when it comes to base 3, we have 0, 1, 2. It ends there. Then when it comes to base 4, we have 0, 1, 2 and 3. So these are the values in the base what? Base 4. That's why here we're saying that the chairman converted the pin to base 4. Why base 4? It's because the base 4 has the digits like 0, 1, 2, 3. And once you go in the original pin, the pin they converted, when you go back there, you really see the pin they converted, you really see that we have this. We have this one. I see you have 1, 3, the highest value 3, so the report is base 4, and they have given the reason. Now next is, let's now convert or obtain the original pin. I told you that in normal counting we use base 10, so the original pin must be in base 10. So that implies that every digit was in base 4. And then what we're going to do is simply to convert from base 4 to base 10. So let's do the next step. So you're picking the first digit from the digits they gave us. Among them was 1, 3 in the digits, and it's in base 4. Now it means that here you're going to convert it to base 10. That's our aim here, because originally it was in base 4, back to base 10. Why base 10? Is because your phone number, the bank pin, mobile money pin are all in base 10, which they're calling the original pin. So let's continue. Now we're going to convert the 1, 3 base 10. First of all, you begin by giving the numbers the powers. So 1, 3, 1, you give the powers basing on from the right. So this first number, you always give it power 0. Next, power 1. If you have a number here to be power 2, another one, power 3. So that's how we go about that. You begin by giving them the powers. Let's now see the next step about the conversion. Now when converting to base 10, we simply multiply. So that's how it goes. Okay, now you realize that here what we have is, in simple terms, you get, in fact, you multiply the digit times the base, then you put the power. And here we have a 1 times 4 power 1. Do the same. The base, rather the number times the base, the power. So that's 3 times 4 power 0. That's what we do when converting to base 10. And apply 1 times 4 power 4, you get a 4. When apply 3 times 4 power 0. Now any number to power 0 is a 1. So that is a 3 times 2, a 3 times 1, which will give us a 3. Now when you add a 4 plus 3, the first digit you get is 7. And that is in base 10. Let's proceed. So in the next context, we are getting now another pair, which is 2, 0. So you give them the powers and do the same. We are going to convert to base 10, which is the original pin. So simply here we multiply still, like I explained. This 2 times 4, then you give it the power. 0 times 4, you give it the power, then you get the solutions. So when you multiply, you realize that this will give you, this will simply give you, now a 2 times 4 will give us 8, and a 0 times 4 will give us a 0. And then you add, you get 8. So far I have 2 digits. You have a 7, and you also have 8. Let's proceed. Continuing. So we are now getting another digit. Remember there were 4 digits. So far I have 2. Now this one, 2, 1, also gives us. We'll repeat the process. So we carry out the multiplications, and we get the third digit. I already explained that. So in the same way we do this. So in the same way we do this, we multiply this 2 times the 4 power 1, 0 times, rather 1 times 4 power 0. But remember, any number to power 0 is 1. So 1 times 1 will give us a 1, and then also, so when you multiply, so this is 2 times 4, which will give us 8. A 1 times 4 will give us 1. When you add this plus this, you shall get a 9. Simple as that. So lastly, let's look at the 1, 2. Now how many digits are we having? Have this one, this and that. So let's see what you're going to have next. So 1, 2, want to convert in the same way. Okay, now and finally, when you multiply, you realize that the answer you get will be 6, and that implies that how many digits are we having? We have this one, we have this one, we have this one, and have this one. How many are they? This is 1, 2, 3, and 4. So finally, we have gotten the 4 digits. So the pin was 7, 8, 9, 6. That is the pin required to withdraw the money from the Sako. I hope the real go and find their money. Assuming maybe the money was not even stolen. Because anyway, I'm not going to that. So we have that as our answer. But then about the curriculum, please remember when they're marking item 1 and item 2, please, we have what we call identification, and we have what we call manipulation, and we have what we call application. So please, application is that conclusive part. After getting the answer, you must always come and give it in statement form, more like a conclusion. Let me rub up this so that you can go into that. So a conclusion, we shall say, okay, the original pin in base 10 was 7896. Now this one is what we call an application. Always make sure every number you do, you must summarize or conclude like this. Failure to do that, please, you will lose the marks. Let's go there. And then that was it about number 1, and that pushes us straight away to item 2. So activity 1, activity of integration for number bases, please, you can use this. However, though, you can as well set others for yourself. We got number 2, and topic 2 is working with integers. Okay, so here we are. So we have activities of activity of integration, topic 2, that is working with the integers. It comes from theme numbers. Please, we have the theme, and then the theme has got subtopics in it. I guess you all know that. You can go in the playlist and check. We commented on what themes are. Okay, so here let's see. We have this question again. Is red ink. So you're saying, now it's coming from working with integers. Now, under working with integers, what should you expect? In fact, working with integers is where we shall learn about the factors, the multiples, the number line, the highest common factors, LCM, among others. Plus, how we can write numbers in figures, and how we can write numbers in words. So that's what we expect under number, or rather working with the integers. And specifically, let's see, where is this coming from? Okay, to begin with, the saying, a senior 1 classroom has been without tiles for the last 2 years, causing students to struggle with dust in the class. The school engineer now is tasked with tiling the classroom floor with measures 54 centimeters by 420 centimeters using square tiles of length x centimeters. The length is not known. The challenge is to find the length of the largest, mark the word largest square tile. The word is largest square tile. The length of the largest square tile. Now, just to brief you a little bit, please, whenever you talk about highest common factor here, you should now think about, still about the working with integers. Highest, you get words which are similar to this word highest, more like largest, maximum, biggest, widest. Those are words which can associate that highest common factor. Then on the same note, have LCM. Now LCM, what should you expect? Now LCM, with it, expect the words like lowest, smallest, or if not, LCM also talks about a repetition. Say for example, maybe we had a meeting today on 1st March, like that. I'm just imagining on 1st March. Then when again shall we have a meeting? Again, that word again brings us to LCM. Or if they bring a question about a repetition, like the trees on the roads. For those who have ever gone to the ends of, okay, the trees planted by Semeika Kunguru by the sides of the roads, those ones there, there's a repetition, a tree after the other on either side. That one also is an application of LCM. Anyway, let's go back to work. Okay, so we proceed. The challenge is to find the length of the largest square tile. The challenge is to find the length of the largest square tile that can fit classroom floor without needing to cut any tiles. Additionally, the engineer needs to help determining the number of tiles required and the total cost for purchasing the tiles. It is known that each tile size is of X centimeters, costing shillings 5,250. Okay, that's some good money. Task: help the school engineer by calculating the largest size. Now I think this one largest is coming back. Please let's all move together. Help the engineer by calculating the largest. But here you have been given two values and they're talking about largest. Please there think about highest common factor or greatest common factor of the square tile that can be used. Okay, the number of tiles needed to cover the entire floor and the total cost of purchase. So here I want to know size of the largest square tile, how many are required on the floor, and what is the cost. Let's go and step into that straight away. Now, since the word largest is telling us highest common factor, whenever you see being given digits in this format, this kind of writing, then you see the word largest, think about highest common factor. Okay, let's go there. So now to get the highest common factor, first of all, let's get a sketch of the floor. So imagine it is a triangular floor, and let's see. That's our room, that's the floor. Now let's see the dimensions. That is our length, and that's our width. So you're going to use the ladder method. Please, there are very many ways of getting the highest common factor. Factor tree can be used, and ladder method. For this time around, we shall use ladder method. Let's go there. So first of all, we shall put those values into the ladder method. You all know that, I guess. Okay, put the values there. And then please, here, what we're going to do next is to see values we can use. But please, when reducing this, we strictly use prime numbers. Let's say, for example, a 2, a 3, a 5, a 7. Prime numbers, please. 9 is not a prime number. We have 11. And so on. So these are numbers we're going to use. First of all, use 2. We only leave 2 if we realize that there's no number which can be reduced by 2. From 2 we go to 3. From 3 we go to 5 onwards, like that. So let's see. So you realize that in this context, when you 420 divide by 2, what shall we get? And 540 divided by 2, shall we get? So you realize that in this first case, you have this. When these two reduced this, you got that. When these two reduced this, you got that. That's okay. Let's proceed. Okay, so here in this part, what happened was A2 was able to divide this and this. That's very good. A2 was able to divide this and this. That worked. Now you see that 2 cannot divide 105 and neither can 2 divide 135. That's why we're now going to a 3. We call it prime factorization. So a 3, when you reduce this, it will give you 35. A 3, when you reduce with this, 135 divided by 3, you get 45. Now 3 cannot divide 35 and cannot divide 45. So we go to now 5. So 35 by 5 shall get a 7, and 45 by 5 shall get a 9. Now one would ask, why have we ended here? Remember, our aim is to get the highest common factor. And how do we get highest common factor? Highest common factor, those are values, please, which in fact those are values which can easily divide both of them. Like let's see, I'll be putting the lines. Has this 2 divided 520? Yes. Has this 2 divided 540? Yes. So this one will qualify to be among the answers we need in the highest common factor. Let's again see. Has this 2 divided 210? Yes. We have the answer there. Has this 2 divided 270? Yes. We have the answer here. So it qualifies to be among the values in our highest common factor. Let's now see. Has this 3 divided 105? Yes. To give us 35. Has this 3 divided 135? Yes. To give us 45. So this one qualifies to be a common factor. Please only qualifies to be a common factor if it can divide here and there. But it divides only one part, then it ceases. Now why did we use these numbers here? You realize that here we don't have any number which can move with the, we don't have any number which can move with, or we can simply reduce 7 and 9. Here we just bring on a 7. Please, this is imaginary value 7 to give us a 1. Now this 7 has only divided 7. It has not divided 9, and so the 9 comes back. So this one cannot be among our highest common factor. So when you go down still, you realize that here we'll again bring what? Maybe 3. And 3 only divides here 3. It is not dividing this. So that's why we have ended here, because the common ones have disappeared in either case. But with LCM, please you proceed up to the end. And LCM, you multiply whatever is here. But highest common factor, we go with these ones which can divide all of them. So let's go there and see. So now shall say the highest common factor is equal to 2 times 2 times 3 times 5. Oh, by that, I forgot now 5, because 5 also divides here to give us a 7 and here. So our highest common factor simply becomes 60 centimeters. Remember the question was, they want us to know the largest square tile. The word largest is the word best from to use the word, or to use highest common factor. If they had said lowest, then we would have used the LCM, but I've said largest, so we use highest common factor. Let's now go and see. First of all, now the largest square tile, in fact here, the largest square tile must be of length 60 centimeters. This is the answer here. In simple terms, the largest square tile must be of length. Our highest common factor gives us the length of a square tile, like that. So let's now proceed. So we want to see now the number of tiles. The number of tiles, we shall say. So now the number of tiles, what you do, you come and get every number here, every digit. This one divided by the highest common factor, this one divided by highest common factor, and that is it. 520 divided by 60 by, now this one is by, not times, but it means by. Please, they read it as by. 420 divided by 60. Now what shall we have in the long run? So what you're going to have in the end is 9. Now 9 times 7, those will be the number of the square tiles. So 9 times 7 will give us 63 tiles. Now we have remember the question asked for, how large should the square tile be, and how many are required. So please, these are the numbers of the square tile. There are 63 tiles required to put up on that floor. Now next we must see the cost. We have seen the length of the tile, how many are they. Let's now see the cost. So but one tile costs 5,250 shillings. So we are simply going to multiply to get the total. That implies that the 63 tiles will be equal to 63 times 5,250, which will give us 33,750 shillings. And that marks activity, the end of activity 2, about working with integers. Let's now move to the next. But I said here, always please conclude. Even at this level, you can say, therefore, at this level, here where we are, therefore, the largest square tile must be of length 60 centimeters. The next, the number of square tiles required is 63 tiles. Then here, the cost for all the 63 tiles required to put up on the floor is 33,750. That's what you must conclude, always. Number 3. So topic 3 comes from fractions, percentages, and decimals. These activities of integration are picked from syllabus books, specifically the learning outcomes. Forget that note. Okay, let's go through this. So now we are having, so you expect things about fractions. The same. The school organized the inter-class competitions for non-candidate classes, Senior 1, Senior 2, Senior 3, and Senior 5. The prize money of shillings 4 million. Oh, this is a big school then. Is to be shared based on classes performance, classes performance in 4 games. So here I think a class which wins will share the 4 million Uganda shillings. Okay, the scores for each class in the game are as follows. So we have the classes Senior 1, Senior 2, Senior 3, and Senior 5. Football, these are the points they got. And now award basing on position. Now here that's the award. Position 1 they give you 40%. Position 2 they give you 30%. Position 3 they give you 20%. Now the remaining percentage is for number 4. Now you add here 40, plus 30, that is 70, plus 20, that is 90. So the balance here is 10. Automatically, we are dealing with the percentages. And even the topic here, subject we are dealing with is fractions, percentages, and decimals. So expect that. Now, what do they want? Help the game master identify the winner and how much each class will receive as the prize money. So now you must come and look into this and see who won in the 4 games. So it means that here, please, in all games, you have all ever participated in the games. You realize that in all games, this word total is highly respected. So it means that in every context, we are going to get the total for each. That is, total for senior 1 in the 3 games: football, netball, volleyball, and athletics. So we must get the total put there. Do the same for senior 2, do the same for senior 3, do the same for senior 5. Then with that, number takes 40%, number takes 30, 20. This one here, the remaining one I calculated was 10. Let's can see how that comes about. So let's start by first of all calculating the total points for senior 1. Now these total points are coming from, we are going to add these values, please. Just remind you. We are going to add for senior 1, we're going to add this, that. And we're going to do the same for senior 2. Senior 3, add this, plus that, plus that. Senior 5, this, and that, and that, and that. Now the owner or the winner in the terms of the total takes the 40%. Let's see. So we start with senior 1 points. That is a 15 plus 15 plus 15 plus 20. That will give us 20 points. Next, for senior 2. Okay, we shall also do the same for senior 3. And finally, the same for senior 5. Okay, there we are. Now still, according to these other points here, what do you expect? Who is the winner if you check? Who is the winner? Let's go by the totals. Who is the winner? Still, even democracy, total works a lot. 65, 70, 50, 60. So it means that the winner was senior 2. So, but here in the question they said that the winner takes 40%, followed by 30, followed by 20. So it means that if you go back here, oh sorry, get this already in place for you. Okay, so according to the above points, let's see who will be the winner. Remember, the first one takes 30. So it means that here, okay, we shall come and say, this one here will take on the 40, is the first. The second one is, this one will take over the 30, like that. And this one is the third, will take over the 20. Now the remaining balance is for this last one. And of course the remaining balance is automatically 10. Why? When you add this, plus this, plus this, plus this, you get 100, which is in percentages. Let's can see that. So the position number 1 is senior 2 and will take 40%. Position number 2 is senior 1, will take 30%. Position number 3 is senior 5, take 20%. And position number 3 is the remainder, which has been 100 minus the total of the other, which will give you 10%. I would explain that. So how will they share the money? It means that the mode of sharing the money will base on the values we have. Like, you will have to get this percentage times the 4 million, the 30% times the 4 million, 20% times the 4 million, 10% by the times the 4 million. Then we see which answer will come up. Let's go and see that. So sharing the money amongst the 14s, let's go there. Put the arrows for you for specifications. So now sharing the money amongst the 14s, what do we expect? So now with this, we shall start with the senior 2. An application will be the 40% times the 4 million. And how much shall we get? You'll get 1 million Uganda shillings anyway. I guess they share it very well. Some good cash. So now senior 1 had 30 times 4 million. How much would they get? That will give us 1,200,000. Okay, let's proceed. Lastly, that's how they get the money. Of course, I've explained how the conversion, the application is done, but let's look into this, please. I'm saying when you cancel this 0 and this, cancel this and that. This is a typing error, please. You realize that multiply 4 times 4, here shall get 1.6. 1,600,000, if you can see that logically. Okay, we apologize for that. So now let's proceed. So senior 2 got 1,600,000, senior 1 got 1,200,000, senior 5 got 800,000, and senior 3 got 400,000. Let's now see what next. So that also marks the end of activity of integration number 2, senior 1. Let's move on. Erase of this. That pushes us to activity of integration 4, and that is topic 4, rectangular Cartesian coordinates in 2 dimensions. Now in here, the rectangular Cartesian coordinates in 2 dimensions is where we get the is where we get to know how we plot the values, the Cartesian plane, the x-axis and y-axis. That's where we go into that, and that is still senior 1, book 1. Let's see what was required here. They said the school administrators have asked, let me get this, there's a pen. So the school administrators have asked the engineer to design a shape of a ceiling of the community school. They provided the engineer with a set of coordinates describing the shape as. So you have the coordinates as that. The points are scattered across the rectangular Cartesian coordinate system, and the engineer must plot these points accurately to visualize and design the shape on a Cartesian plane. Now let's underline some of the words here. So I'm going to underline the word the engineer must plot. Underline the word plot. So we're going to plot those points and accurately visualize, design the shape on a Cartesian plane. Cartesian plane, the x means the xy plane, x-axis, y-axis. And let's go and see that. So help the engineer by plotting the coordinates on a Cartesian plane and determine the overall shape. So you go about plotting, plot this, that, the end, and join the points and see which shape comes up. Anyway, we are also becoming engineers in mathematics before even joining campus. Okay, that's great. Let's go and see. Okay, so with this we have to use a graph paper strictly. Let's go there. So we first of all label our graph. So we have our y-axis, x-axis. Next is demarcating. We demarcate. We are demarcating, please. Okay, after demarcating, let's now put the values. Midway put the 0, which is the origin 0, 0, 2. So please, you can choose on the scale. We all know to select scale. I'm using a scale of 2 on the x-axis and a scale of 1 on y-axis. So there we are. You just put those values, please. You have a graph paper. Okay, now let's start off with the plotting. Let's start off with the plotting. So we have the other coordinates. Please, let's go about the plotting. So you are plotting a coordinate 6, 0, 6. We have the coordinates here, please. We are plotting these coordinates here. So you also make a follow-up and plot them. Then we see and compare our work later. So let's see. Next, I plotted the coordinate negative 2, 3. Coordinate 2, 3. A coordinate 5, 3. A coordinate 5, actually here it was 5, negative 3. Then here it is actually negative 5, 3. What you have plotted here, please. What you have plotted here is negative 5, 3. Please, here it is a 4. It means that here we are leaving out a 5. Here is a 6, we have there a 7. Here was a 2, we have here a 3. So that's what I'm using, simple math. Let's go and see. So let's proceed with the plotting. Please do the same. Do the plotting. You all know how to plot. Let's all get there. Then after plotting, let's try to join the points. Join the plotted points, but of course, presentably. You realize that here, you see, when you have this, after plotting, please, look, which shape shall come up here? Now we start from up. You see that when you join this, to that, to that, to that, back there, back here, there, okay, there, there, and there. I guess you can see something there, which is something like a star. Okay, so I think the ceiling, the design of the ceiling was meant to be a star. Okay, in simple terms. So let's go and see the real drawing. That's just a rough cut bit. Okay, so we join the points. So in simple terms, that was the shape which was required. But of course, let's give a conclusive remark, a conclusion. Please don't forget to label the axes. We have here the y-axis. Don't always forget to label the axes, x-axis there. Then also you need you can put a title. Please, you can put a title. No harm. In fact, to avoid problems, you should always put a title in every graph work you do. So in conclusion, I shall say the shape needed is a 5-pointed star. So it is a 5-pointed. The shape needed is a 5-pointed star. Let's go and see. Sharp pointed here, it is the first sharp pointed, second, third, fourth, and fifth. Take note, please. We also have an 8-pointed star, and I think that one you go to see it in the first prototypes they brought when the new curriculum was first invented in 2020. The prototypes they brought, or with them, the activities of integration have an 8-pointed star. Here we have a 5-pointed star. You have to be specific. Okay. Let's now move on. That will push us to item number 5. So item number 5 we have geometric construction skills from theme geometry and measures. Please, I'm not paying attention to that because I want us to solve such that this video doesn't take that long. That's why I'm not going through that, but the theme is geometry and measures. The themes go interchangeably, of course, however much you're dealing with the same class in year 1. Let's see now. Under construction is where I learn about circumscribing, inscribing, constructing various angles, bisecting, among others. So let's see. A landowner has a triangular plot of land, of course, start off. Has a triangular plot of land with a base measuring 70 meters. These two sides of a triangle are inclined at edges of 75 degrees and 60 degrees to the base. The landowner wants to construct it a circular well, okay, which will minimize the space available within the land, but he is unsure of the area it will cover. Task: advise the landowner about the maximum area the circular well will occupy. Okay, now the maximum area here, what you should know is that this landowner has this kind of land like this, with the sides of a triangle inclined, side of a triangle inclined, side of a triangle inclined, at which angles? 75 here 75 there. Then here we have what? 60 degrees, like that. The base is 70 meters. Then they want to now build the circular well inside. Now look at that whole rough cut. Tells you about inscribing a triangle. Let's can see. So to start off, let's go and see. You always have to begin off with the sketch. Let's see the sketch. The sketch of a triangle is that with the circle inside. Then the base is also 70 meters. Okay, now remember, for us, when you're trying to figure out with this, remember, what do they want? They want to advise the landowner about the maximum area the circular well will occupy. Okay, so it means that before you have to construct this on a piece of paper, then you also try out. But remember, your piece of paper, its length cannot even reach in meters. Therefore, you advise to convert this into centimeters first, and that will require a scale. A scale here, you can use the digits, which can equally divide the value you have there. So let's see. So a scale, say that 1 centimeter equals to 10 meters. Please, here a scale can think about any value. More like the way we do in bearing. Please, if you have not looked into bearing, you can go in the playlist and check. There's a topic presented there, a full topic of bearings. We explained more about these scales here. So now let's see. Let's convert the length into centimeters so that you can be able to construct and see what you'll need. So the length of the base equals to 70 divided by 10, and that will give you 70 centimeters. So you have now seen. But remember, what we left out here maybe in our sketch. What we left out here maybe in our sketch was, please take it that here we left this out. Here we have a 70, take it as that. And then here we have a 60 degrees, like that is what we have. So that is it. So that's what we had left out in the sketch, but make sure you put it there. Let's now go and see the accurate drawing. So first, you shall begin by drawing a long line. When constructing, you draw a long line of unknown length. Of course, it should be straight. You all know what is required in construction, so I can't go off that. So next, you shall mark off the 70 centimeters using our ruler. So what you do, we shall put a marking. You now put a marking here. After putting it there, then you can measure using a ruler and make sure that this length here is 70 centimeters, sorry, after converting. Why have you converted to centimeters? Because your book cannot go up to the meters. Meter is too big. Meter is too big. For those who have ever done physics practicals, the long rulers used there in the practicals, that is just 1 meter. Now imagine, can it fit in your book? No. So therefore, we convert from meters to centi. Okay, meters. Now let's see what happens next. Okay, here. When we move this, realize that we shall now have to label it. That is 7 centimeters. Then remember, at this level, what I meant to do. At this level, I'll explain. At this level, we need to construct here an angle of, actually this was 75, sorry. This was 75, not 70. Okay, we need to construct an angle of 75. In fact, an angle of 75 here. But I think in our writing it was 70. But we shall have that corrected, no problem. So we have constructed an angle of 70 here. How shall we go about that? How shall we go about that first? Let's begin off. So you first of all draw a semicircle. You start by constructing the angle of 60. You start by constructing the angle of 60. Now, how shall we get that? Maybe we can use another approach whereby to get the angle of 75, we can start with our 90. Our 90, okay. Let's construct 90 degrees. So to construct 90, you only have to construct 90, please. We put here a compass, put a compass here, and make that arc. Put a compass here, and make that arc, and later draw a line there. That will be our angle of, okay, 90. So, however, since we are just on our way of finding 75, we cannot put it as a bold line. So it will be dotted to mean that we have only used it to go towards what we want. So draw an angle of 90 there. I've used dotted lines. Why? Because it's not what we want. So that implies that here, it means that here we are remaining with 90, but we need 75. How shall we get 75? It means that here, when you construct here 60, this will be 60. And if you have, if from here up to here is 60, please look, remember it was 90, it means that from here up to here is 30. So if this is 60, if you bisect this one, if you bisect this 30, you will get 15 in the first part. From here up to there, 15, and from here up to here also 15. But of course, when you count from here up to here, you'll have 75. So therefore that means that 60 plus 15 will give 75. Then you bisect this, you'll be able to get that 75. I think let's get there. Okay, let's see. So we draw an arc here. So that arc implies that we have a 60 there, I've explained. So you're going to bisect. It means that we shall stand here, make an arc, stand here, we are bisecting, make an arc, then you draw a line all through there to join there. So let's see how that comes about. So that will be make an arc, another arc, then you can now have our solid line. Please, I'm apologizing, here we put a 70, but it's a typing error, it's meant to be 75. So that is now our, okay, it appears like 70, but it was meant to be 75. So this one is meant to be 5. Please bear that in mind, it is 75. Let's move on. That's done. So one part of the triangle has been completed. Let's go to another one. Now here we're going to construct an angle of 60. How do we begin? Semicircle. And now a 60, you all know how to construct a 60. You can either put here, in fact, you put here, draw a semicircle, don't change the radius. You now come and put your compass pointer here and make an arc. Now that 60 will face there. But you don't want that. And of course, when it goes there, we shall not be able to formulate a triangle with this. So it means that that 60 must be constructed this side. That 60 must be constructed this side. Like here. So here, you realize that put here a compass, make a semicircle, don't change the radius, come and stand at this point, compass pointer here, and make an arc. That arc means that from here up to there is 60. So you draw that. So the angle here will be 60. Let's kind of step into that and see the way forward. So we have constructed an arc there. Then we do a solid line, and then we shall call it our angle of, okay, this one here will be our angle 60. So here will be an angle of 60. Let me just put it even before it comes. So here we have 60 degrees. From here up to here is 60 degrees. So that implies that we can now proceed. Now next, remember, they have to put a circle inside. They put a circle inside. Then what must we know? Now when you put a circle inside, it means that we are inscribing. And if you check your neighbor last year, please, they set a number on this part here. So if a circle is inside, it means that we are going to inscribe. We are going to inscribe. And what to inscribe, please, we bisect any two angles. Please, to inscribe, we bisect any two angles. You can check in the notes. To inscribe, we bisect any two angles. So let's do that. I want to bisect this angle and this angle. Bisecting means, okay, put here your compass, make an arc, make an arc. When your compass is at the compass pointer is here and the pencil, put a compass pointer here and adjust. Make an arc, make an arc. After there, come and stand at one of these arcs, make an arc there. Now here we're bisecting this angle 75. So also put here and make an arc. From there, draw a line midway. Afterwards, come and put here also. You can put your compass pointer, or you can just based on these values we have in position. Here, put a compass pointer here, make an arc. Compass pointer here, make an arc. After there, you draw and join. Now where they meet here is the center of the circle. And how will you get that? You're gonna put there the compass pointer, adjust up the median of the triangle, and you draw that circle. That's the rough cut of what you are going to go through. Let's see how that comes about. So we are bisecting here and you're making the arc. We have put the compass pointer at this level. We are making an arc, which is there. Put here also, make an arc. Then after there, join the red lines. Then also come here, make an arc. Come here, make an arc. Then join the lines. So this one becomes the center of the circle. Let's put that. Anyway, let's name this angle first. So it is now our 60. Okay, now okay, maybe just to go into this, so you realize that this circle which has been here, you put a compass pointer here, you put the compass pointer, adjust your pencil up to the median, then you smoothly draw that triangle without forcing life, like we have it there, hoping it works out on your side. Now remember, the aim of these people was to, okay, advise the landowner about the maximum area the circular well should occupy. Now, circular, the maximum area of the circular well is, the well is circular, so which is a circle inside the triangle. So here they want specifically area of a circle in simple terms. But to find the area of a circle, you must have radius of a circle. Now, do you have radius? Let's go there and see. You don't have radius. So you don't have radius of a circle. But how shall we get radius? Please, some people, anyway, I don't know. But some people always just come and measure this direct. Please, that is wrong. In fact, it's very wrong. It's not okay to do like that. To get a radius, we go through some necessary steps. Now, to get a radius, what you do? You shall come and put this. Put a compass pointer at this point here. In fact, let me use a different ink. Put a compass pointer at this point. Then adjust your pencil up this side so that you can make an arc there and there. You can make an arc there and there. In fact, in the same position, let me remove this. So you put a compass pointer here so that you can make an arc there. Don't change the radius and make another arc there. Here we are aiming at changing the radius, finding the radius of the circle, not just measuring from anywhere. So after that, come and stand at one of these and make an arc down. Stand here, make an arc down. Then from there, draw a straight line to pass through the two arcs. Now, from here up to the center gives us the radius of that circle. Those are the steps we need as far as the construction is concerned. Let's go there. So you have made that arc and another arc, I've explained. So stand here, make an arc. We're going to stand here and make another arc. There we are. Finally, we join. Like that, now the radius to be measured from here up to here, and that radius found to be. So the radius is equal to a 2.2. But remember, this is in meters, a 2.2 meters. In fact, let me put this. A 2.2 actually centimeters, because we are constructing, which is in centimeters. Now, but remember, the way they are calculating is on the ground. So you must convert this one here into what? Meters. And how shall we do that? 1 centimeter is equal to 10 meters. So converting a centimeter to meters, shall have to multiply. Simply, you say. So now our radius will be 2.2 times 10. And that will give us, radius will be now 22 meters. Next. Now from area of a circle is equal to pi r squared. Let's see. Now they didn't give us the value of pi in this question, but if not given, then you always let the pi to be anything you want from these two, 20 over 7 or 3.14. For me, in this question, I'm choosing 22 over, rather, I'm choosing 3.14. Let's go. So area is equal to 3.14 times 22. Now remember, the radius is 22, but squared, we have that, so the area will be 69.08 centimeters squared. Anyway, this is an error, I think. Typing error here, please. This is meant to be meters squared, centimeters. Let's go there. So you have now come and summarize and say or conclude. The maximum area of the well is 69.08 centimeters. Rather, it is in meters. It is in meters, please. This is in meters squared. Simple as that. And that straight away pushes us to activity of integration number 6. Let's get there. Now on part 6 you have sequence and patterns. Now sequence and patterns here we look at a lot. Of course, right from primary they were always giving us some sequences, and required was to complete them up. So it says, the school canteen manager has noticed a consistent pattern in student attendance at the beginning of every term. Specifically, the number of students increased by 10 each day, starting with, so mean that every day which went, they increased by 10, starting with 200 students on the first day of June. So we must put this into consideration, please. Realize that here, they started with 200 students, but every day they were increasing by 10. So it means that after a day, they went to 210. After another day, they went to 220. After another day, they went to 230. Please, you must figure that out. After another day, they went to 240. Now, I think that we have a sequence here. We have here 200, 210, 220. There is a sequence that every day the students increase by 10 each day, starting from the 200. Anyway, it seems to be a great school indeed, having such an increase every day. So, specifically, the number of students increased by 10. Okay, we have that. Students on the first day of June, the school manager wants to develop a mathematical formula. Now, wants to develop a mathematical formula. Of course, under topic sequence, we have that part of generating a family phase sequence. And I guess that's what we'll need. To calculate the number of students on any given day, use it to calculate the total number of students by the end of June, and determining which day or the nth day the student population will reach 900. So they want us to determine which day will the students population reach 900. So they're giving us something. Now take note. We shall take the students population is P and is 900. Please, in this context, then the days, the question has stated, we call them nth, like that. Okay. This information will help the manager stock up the supplies accordingly. Help the school manager develop a mathematical formula, calculate the student by the end of June, and determine the specific day, and the day when the student's population will reach 900. So let's see how that comes about. Let's go there. So I use a different approach, please. There is that A-level approach, but I don't know whether it is acceptable here. Personally, I say it is not. There's that A-level approach where we have the first term plus the second term. It doesn't work here. Please, this is best for O-level. Okay, let's go there. And I use. So now that is our sequence. Remember I said it was 200, went on increasing by 10, 10. So that is 200, 210, 220, 230. I think a sequence here, I want you to see something. A sequence, from here up to this, we have a 10. From here up to this, we have a 10. From here up to this, we have a 10. So it can be continuous. This does mean that it is not ending. It is proceeds. So that's the sequence. So and here they had asked for help the school manager develop a mathematical formula and calculate the. Okay. So now this sequence will give us everything. Let's proceed. So in the formula, we shall have the nth value, the sequence, and the working, which we shall need. Let's proceed. Let's see the way forward. Now, in the working, we shall say, remember, I want to put this clear. Remember, now, these ones, we call them terms. 200, 210, we call them terms. So the nth value here, we call them terms. Now, this one is the first term, this one is the second term, this one is the third term, this one is the fourth term. Please put that in consideration. Being the nth value, it proceeds, and here it goes up to the nth. Nth means that unknown value. That's what the nth means, that unknown value. Okay, now let's see. So we want to so nth, sequence, and working. So the sequence, in the sequence, at the first term, we have 200. Let's can see. The sequence in the second term, we have 200. Now the manipulation which we want to manipulate here. This implies that, please, you go slowly. I want us to understand this. So in this term here, we have only 200. There's nothing which added. It is the first term. So I leave it the way it is. Now in this working part, allow me to do this. Put those lines there for clarification. So when you have sequence and term number 2 is 210. But how do you get this 210? This 210 came from the 200 plus 10. Do you see that? 200 plus 10, which gives you this. Okay, then I'll explain the rest later. Let's go. Okay, now with this, I guess now I'm passing the science we're going to use to go about this. We have 220. How do we get 220? 220 was everything must begin with this guy 200. 200 must begin the story. So if we begin with 200, how shall we get 220? We add 10 plus 10 two times. Okay, let's proceed. The next, in fact, so then next we have this. Now next we have this. So we realize that, let's see, we have here term number 4. Term number 4 is 230. How did they get 230? Remember, the whole thing must begin from 200. That will begin the story. So it is 200 plus, how shall I get 230? It is plus 10 plus 10 plus 10. When you add this, you get 200. So here it means you must know the value which is increasing here. You keep adding it onto the first value such that it can exhibit what you have here. When you add 200 plus 10 plus 10 plus 10, you get 230. Then, what do you expect? There is something we must see here. So let's put the lines there by the for clarification. Okay, now I put the lines there. I can now resolve this. Now there's something I have to see. In fact, let me just put everything first of all, so that we can reason out on this. We want to see which formula shall we use. Now in this context, I want you to see. We are now seeing we shall relate this. We shall relate this. Okay, we shall let this, let's start from here, this 2 plus this last bar. Here we expect to see that we have to multiply this 2 times the 10 to give us the answer which you have here. But realize that instead of a 2, here they have a 1. We always relate with that. Another one, here I have this 3. Relate it with this 2. Because 200 is constant, a 10 is constant. A 200 is constant, a 10 is constant. 10 is constant, 200 is constant. Now you see which values are changing. This 2, it becomes a 1. This 3 becomes a 2. And finally, this 4 becomes a what? Becomes a 3. Now what does it mean? This implies that here, to get that 1, they said 2, in fact let me use different ink here. To get that 1, okay. It means that to get that 1, they used different ink here. They used, to get this 2 here, to get this 1, they used a 2 minus 1. Which 2? This 2 minus 1 to give us that 1. Then here, how they get this 3, this 2? They said this 3. So every value here minus 1 is what they multiply with 10. Okay. This is that way. Every value here. Okay. Okay, sorry for that interruption. Let's proceed. Okay, let's proceed. Now, I was trying to explain here that, please, you see that here they subtracted minus 1, then they multiplied here. So 200 plus, now this 3 minus 1. Now here also, a 4 minus 1 is what they are putting here as a 3. Now it means that what if, since you want to get the nth term, what if when you don't know the term which is next here, I can put in a letter, I'll put n. What if when the term is n? It means that we shall keep the trend. It will be 200 plus, the trend remains, bracket. Now here, the number here, they reduced by 1, meaning that here we shall put n minus 1. So that will be n minus 1. It is in the brackets as a single value. Then also times 10. Please, that one will give us now the formula what we need. So always you arrange in this order, then you put nth at a certain value such that you follow the order and how the trend is moving. Let's go and see how that is done practically. So let's go and see how that is done practically. So practically, let's see. So if you prepare your nth term, I resolve this. So if you prepare your nth term, let's see. Now here we shall come straight to this level here and see. The 200 is constant plus it is the changing is here at 3, reduced by 1 times 10. Now I think that here I want to see something here. Please, this ones here were not changing all through. Even the 10s have not changed all through. But what was changing? it was only the values here, the values multiplying by 10, they are the ones who are changing by 1. So if you have 4, it becomes a 3, meaning 4 minus 1. If you have a 3, it becomes a 2, meaning 3 minus 1. If it's a 2, it becomes a 1, meaning a 2 minus 1. So if you have n, it will be now n minus 1 in simple terms. Let's proceed. Okay, now let's start. We can conclude. So our formula will be population is equal to, now the population, the formula is done which will give us a population. So therefore you just come and say that the population they want, this one must be equal to the formula we're going to generate, and let's see how that comes about. So it's equal to 200 plus n minus 1 times 10. Now simplifying, we shall have population is equal to 200 plus, you expand, you realize that here. Please here you realize that if you multiply 10 times n, you get 10n. Then negative 1 times 10, you get a minus 10. There we are. Let's see next. So population will now be equal to, when you simplify, population will now be equal to, when you simplify, population will be equal to, now when you subtract 200 minus 10, you get a 190. Now the 10n remains. So the formula is 190 plus n. But remember, this n here, let me first resolve. Remember, this n here is a symbol for the days taken. Take a note. I've gotten the formula. Days. Meanwhile, this one is population as usual, you can see. So this is the number of students equals to 190 plus 10 times the number of days. And this will help us to know how the population will be changing. Okay, let's proceed. So you're saying that when the population is equal to 900, why this? Because somewhere they have said, they said in the question that, and determine which day or anything day, we are picking from here, n is the days, anything day the student population will reach 900. So don't have to find the anything day when the student population is 900, but anything day, n stands for days. So anything day when the student population is 900, means that the population is equal to 900, which they want to get the value of n. So that will be population, from the formula, population is equal to 190 plus 10n. There we are. Now we are substituting for this. Realize that the population is 900. Let's equate 190n plus 10n, 190 plus 10n. Now the value of n will be the number of days. Let's proceed. Okay, when you collect like terms, you will have that. And finally there. So this means that here, please, you have collected like terms. This 190 has come this side, and crossing the equal sign, it becomes a negative. Subtract 900 minus 190 to give you 710. Now divide both sides by 10. That's the next step, and I think you shall get a 71. Remove this. So let's go and see how that comes about. So in divide both sides, 10n is equal to that. Okay. So in divide both sides, the answer you get is your n is equal to 71 days. So please here, I want to explain once more here. So it will take them 71 days to reach a population of 900. However, they began on okay, first day of June. So they were asking for which specific day. Please here you can decide it to. I will give you a hint, though I will leave it the way it is. You begin by converting these days into weeks. These days into weeks, and from weeks into months. In fact, if for someone wants to understand how you can deal with this value properly, you can refer in the playlist under the marking guide of Mathematics 2024. You can check in the playlist item 1 specifically. At the end part of it, we go to see how we can solve this question of this kind, and you get the specific day. Okay. If there's any problem, please you put it in a comment, and then maybe I can get to you, or you can inbox me on WhatsApp on the number which appears there when the video is starting. So Let's move on. So it will take them 71 days to reach a population of 900 students. Let's go on. But remember that June has 30 days. Now, why are we using June? Here they're saying, there's something they said here in the question. They said the school canteen has noticed. Okay, I want to pick this part of the month. So specifically, the number of students increased by 10 each day. The number of students increased by 10 each day, starting with 200 students on the first day of June. So on the first day of June, just they were increasing by 10 onwards. So June has how many days? 30 days. Means that in June, how many students do we have? Because they're saying, help the school manager develop a mathematical formula and calculate the student by the end of June. So by the end of June, those will be 30 days which have elapsed. So it means that we're going to see the number of days in the June, then we see which population shall we have in that 1 month. And that is why we are going to use this. Hoping we are together. So now I said but June has 30 days, meaning that the 30 days is the value of n, which is 30. But from the formula, population is equal to 190 plus 10n. Now we're going to substitute. Remember here, we have this value of n. So, okay. So we have this value of n here as 30. So you're just going to substitute and get it as the population. Let's see. So when you see, we substitute, it will be 10 times 30. And finally, our answer will be 490 students if you add well. If you add well, have 490 students. So those will be the students which will be there by the end of June. End of June, June has 30 days. So it then means if they had talked about February, what would you say? If they had talked about October, what would you say? Please, you must be knowing the number of days in every month. Of course, they can bring anything out of the blue. Now let's summarize. Our summary will be the number of days required and the number of students got. Let's see. So we shall say that by the end of June, there will be 490 students, and it will take students, and it will take 71 days to reach the population of 900 students. I guess we are all together there. Okay. Now you would ask why I will not putting the marking areas. Please, the marking may be based on a teacher. That's why last year they did specify the marks in the brackets of every question. They were not specifying, so it means that the marks can vary depending. Apart from which contradicts with what they told us at first that every item has 20 scores. Yes, it may be, but on some occasions things may be different. So that's why I'm not putting. Maybe in the forthcoming videos shall have to step in for that. Let's go to the next. So next we go to topic number 7, and that's from geometry and measures as a theme. Topic bearings. Please. Okay, now still about bearings. If you want to learn more about how bearings goes, please go in the playlist and check. There is a full topic of bearings. You go there and revise it such that this one of these examples become more and more simple. Let's go through it. So I think that a tourist group in Uganda is visiting 3 sites A, B, C by helicopter. They began their journey at point S, traveling 300 kilometers on a bearing of 315 degrees to reach site A. Afterward, they changed the course to a bearing of 250, flying 350 kilometers to site B. From site B, they flew direct south for 400 kilometers to site C. Unfortunately, the tourists fell ill at site C, and they now need to return to the starting point S as quickly as possible for medical attention. The group 6 helped to find a shorter direct route from site C back to the starting point S, optimizing their flight path for a faster return. Task: help the tourists determine the bearing and distance on direct route they should take to reach the starting point from sites in the shortest time possible. Okay, let's see. Sorry for that. Okay, now let's go and see how this sketch can come about. Then we can go to the real work. So let's start. Now let's begin with our source S. This is our S. I'll give a simple sketch. They're saying a tourist group in Uganda is visiting 3 sites A, B, C by helicopter. They began their journey at point S, traveling 300 kilometers on a bearing of 315. Now that bearing of 315 from here, would be something like this, up that level. So that bearing there, you now come here and draw a line in front. Allow me leave it there. What was the distance? The distance is 300 kilometers. Please, I'm getting a rough cut of this so that I can go to your work. 300 kilometers. That's 300 kilometers. Now to which point? Okay. To site A. So it means that in front here is where I'll put my site A. You all know how bearings go. If not, you go in the playlist and check on it. So to site what? A. Please don't forget the north and so on. Okay. From there now they saying, afterward they change the course to 250 degrees. Now remember they're on site A and they change 250 degrees, and 250 degrees will be somewhere here. It ends there. So there also you draw a line to move in that direction. For how long? Flying 350 kilometers. So 350 kilometers. Please, I'm getting a rough cut of this so that we got the accurate, the real sketch when you have seen what they're doing here. To site B. So it means that when you come here, in front is site what? Site B. This one's B in A, and this one is our site what? B. Okay, great. From site B, they flew directly south. So here I have north, east, west, and south. So they flew directly south. So south is here, down. South is just right down here. In front there is where we shall have now our point what? Point C. Okay. For how long? For how long? C, to return to the starting 400 kilometers to C. So here you have 400 kilometers to C. Okay. Now that's as quickly as possible for medical attention. The group 6 to help the 6. Okay, we have point S as quickly as possible. The group 6 help to find a shorter direct route from site C. So they are now at site C. Remember they started from S, but they are now at site C. They want direct route. So their direct route will be this. From C directly to what? To S. That's the direct route. Direction and distance. Direction means the bearing. Okay, let's go there and see the real sketch. So first, I've explained that. So you need to give us a title first of all. It says sketch drawing showing tourist's journey in the 3 sites A, B, and C. So you need to always put a title as far as the bearing numbers are concerned. Then let's go into the sketch. Please, I've explained how the sketch comes about. So here we shall just have to move. The sketch, it may not move in order, but so long as you know what is there. So this is how our sketch will appear. I've explained. So that's how our sketch will appear. Let's put the degrees there. You cross check. Please. And that's enough. Now after having the sketch, next step must be a scale. Now why a scale is because we are going to construct this on our graph papers, but we can't have a kilometer on a piece of paper. So we need to convert this. Okay, let's go there and see. So the scale we're going to choose is 1 centimeter must be represented by 100. In fact, the scale here must be a number you can divide these ones here equally. You can use 50. Personally, I choose 100, but you can also use 50. So 1 centimeter is equal to that. And that's how the conversions will be. When you divide the 300, will give you 3 centimeters. When you divide the 350, will give you 3.5. When you divide the 400, it will give you 4 centimeters. As simple as that. So you realize that here we have this. We have the 300, it is now 3 centimeters. We have this 330, it is now 3.5 centimeters. We have this 400, it is now our 4 centimeters. Now this one here can be drawn in on a graph paper because the graph paper maximum is in centimeters, a kilometer is too big as far as that is concerned. Now, this in simple terms, our sketch. This one is our sketch, that one there. Please, to remind you, I drawn it for you here in a rough cut so that you understand. So it approximates to that. When we get there, let's move on to the next part. Now, next part we call for real accurate drawing. An accurate drawing must be done specifically using a graph paper. Mark that. So you're saying an accurate drawing showing a tourist journey in the three sites A, B, and C. Now, as per the sketch, come and see. After doing the sketch like this, please, you may choose to begin from anywhere you want. You can begin from C, B, A, or S. So anywhere, it still works out, as you can see. Now, let's begin by, first of all, putting up. Let's begin with point. Let's begin with point S. Now, our point S is there. Then, what do we require on point S as per the sketch? Point S has 315 degrees. Let's can measure 315 degrees. So the 315 degrees will be that. So we draw there an arrow, but the arrow you're drawing is how long? The arrow you're drawing is 300. This one goes with that. This one goes with that. There's arrows. This one goes with that. So we are measuring now 3 centimeters. Instead of the 300, it is now 3 centimeters. Let's go there and see. Okay, we have that. The next. That is now our 315 degrees. Now we're going to point A. That's 3 centimeters, labeling the distance. We now go to point A. Now at point A must measure 215 degrees. There we are. Please, you must always use a protractor. I guess you know how to use a protractor. If you don't know how to use a protractor, please refer to the videos on bearings on the playlist. We explain that. That's our point A. We're now going to point B. Okay. And that is 3.5 centimeters explained. Now don't forget this north. You must put their bearing numbers or refer to the topic explained. Now this is our point B. That's now our point B. And of course this means that, let's proceed. So this will be, now downwards, if you check on the sketch, from B downwards, here we have B, it has to be 400 centimeters down. Right, which will be 4 centimeters down to C. So let's go and see there. We have done that already. 4 centimeters, and now point C, mark it off. That's our point C. Now next, remember, they want us to know the direction from C up to there. Direction is an angle, then also the distance from here up to there. So please just go and measure it using a divider or a ruler. So the shortest route is this dotted line from here up to this. You see that it was a long way from S, all those corners, to C. However, you can move from here direct to this. Time saving. Let's see. Okay, so let's still continue with our work. You realize that we have now constructed up to point C. Now they wanted us to, at this level, this question. So they said, help the tourist determine the bearing, and now bearing and distance on direct route. They should take the bearing and the distance on direct route. Remember the direct route, that dotted line we have. So let's go there and see. So we have from CS, that distance, we need it. And when you measure, please, you get 6.4 centimeters. And we go about converting. Remember, we said that from our scale, we said that 1 centimeter is equal to 100 kilometers. So to convert, we have used this. So to convert, we have used the we are getting 6.4 centimeters. You multiply them with 100 to get the real distance on the actual ground. So to be 640 kilometers from C to S. That is it. Now let's go to direction. The direction means that we are going to, okay, direction means that we're going to measure the angle here. From here up here. Remember, bearings are measured from north clockwise. That's how we shall measure that. So let's go and see how it comes about. Okay, good. So we'll try to measure. So you now say that the shortest direct route is SC with a distance of 640 kilometers. We have now, of course, I said you must always come and conclude. You must always lay down the conclusion for everything you've done. So let's see. So the angle you have measured from north up to there is 50 degrees. So let's come conclude. So the bearing of S from C is 058. By the way, this was meant to be 58. Let me just go and clarify this. These were typing errors. However, it's good you are getting them corrected. So this is 58. There, take it that is 58, please. Degrees here, that there. So, but when you're writing, bearings are written in 3 digits. Those are the compass bearings. We have 3 bearings and compass bearings. This is a true bearing. You must have digits. A compass bearing is one which has north 50 degrees, maybe east. That is a compass bearing. These ones must be 3 digits, and that's why we have that. And that marks the end of that. Let's straight away go to part 8. So part 8, they're saying the builder has received a sketch of a foundation, and part 8, please, it's coming from general and angle properties of geometric figures. That's topic 8. Okay, the builder has received a sketch of the foundation's design, but the diagram does not provide specifications. But the diagram does not provide, specifications. But the diagram does provide specifications for some angles between the walls. However, the builder has been given a detailed plan of the building. He seeks a clear instruction to calculate the unknown angles to ensure the foundation is constructed accurately. Support design. So this is a foundation. We have this angle, we have this angle, and have that angle, and have that angle. Okay. So help the builder by providing a step-by-step method to calculate the unknown angles using the available building plan to ensure the foundation meets the required specifications. So in this task, you just need to get this angle, this, which the engineer will use to construct. But before we start, anyway, let's just have to, first of all, comment on this. Now look at this, please take note. Before we go anywhere, just know, the angles which make a letter Z, like here, angle there and angle there, we call them alternating angles, and they are ever equal. Alternating angles and are ever equal. Say for example, look, we have in here this, and that. So this angle here is also 2x. Anyway, shall go into that. So that's a brief intro. Let's now go and see how the whole thing is done. So when you go into the real work, you realize that you have. So that's our design. Back again, let's see. So we shall take it that when you look at this, please, we want to get the angles of the unknown sides. But look, this one's here, this angle plus this angle plus this angle, they are all enclosed in a what? In a triangle. So therefore their sum must give us 180 degrees. Let's go there. So 2x plus 2x plus x gives us 180. We are adding this plus this plus this to give us 180. What next? When you simplify, okay, so finally we get 36 degrees. Please, when you add this, you get a 5x. Now here, divide both sides by 5. This will cancel away. Divide both sides by 5. It will give you a 36 there. So our angle there is finally a 36. We have got it from the logic that the interior angle sum of any triangle is always 180 degrees. Let's go there. So I'm trying to redraw again. So from the computation, so what I'm realizing here is, please, when we have here as x, so here 2 times x, which is 36, will give you, this one is giving us a 72. This x is 136 here. This 2x is 176 here. But remember, this side, look, this one, that line, it might be straight, but as long as you see it, and that line, and back there, form a letter Z. form a letter Z, and it means that the angle at this point must be equal to the angle here. Do that angles forming letter Z. If here you have 72, even here you shall have a 72. Those are alternating angles, if you can see that. Let's get the rest of this. Those alternating angles like you're seeing there. Now let's see. Now still have alternating angles, then what must we see here in the end? These are angles on a straight line. Please check here. These are angles on a straight line, meaning that 36 plus 72 plus y gives us 180 degrees. Reason, angles on a straight line. Let's see that. So 72 plus 36 plus y gives us 180 degrees. So when trying to calculate like terms about finding the value of y, shall now come up with that. So to calculate like terms, you'll have the value of y as 72 degrees. Now let's see the whole design. When you draw it, what will be the whole design in simple terms? Whole design will be, I'm just redoing what you have up there. Whole design will be, of course, whole design must have angles. So you must have a 72 there, another 72 there, a 36 there, and finally a 72 at that level. And now it means that the engineer must come, must draw, these are the answers you should get as far as constructing the foundation is concerned. Okay, so as of that, let's now go to the next, and that is chapter topic number 9. So number 9 they are saying, okay, it's coming from data collection and presentation. Please, in here is where you look at the where we look at the discrete data and the continuous data. Then also in there you look at the how to construct pictograms, how to draw tally charts, how to draw bar graphs, how to draw line graphs, and so on. So among the learning outcomes should be that students must be in a position to draw a line graph, rather a bar graph, and we shall step in for that. They say a group of primary school students, get some ink here. A group of primary school students have been assigned to create a bar graph using the pie chart below, which shows the subjects offered by students since they haven't pie chart. Since they haven't covered bar graphs in class, they are struggling. The teacher provided one additional clue. 60 students are enrolled in biology. Okay, great. Task: create a bar graph representing the number of students enrolled in each subject. So in check you have 150, 45, 90, and the colors. For mathematics it is 150. For physics it is 90. For chemistry we don't have. For biology we have it as 45. So now they want us to draw a bar graph from a pie chart. Let's go there and see. So first of all, let's go there and see. We have begun by drawing out their pie chart, and we want to clarify and put the letters there. You allow us to use M to mean mathematics, and allow us to use P to mean physics, allow us to use C to mean chemistry, and allow us to use B to mean biology. Meaning that biology has 45, math has 50, physics has 90. Now this one is missing the C, and can be able to get that. So we all know that when we add everything in the circle here, the total answer we get is 36. That's 360. So you get the chemistry plus physics plus math plus biology max will give you 360 degrees. Of course, let's plant in the values. Okay, now this means that physics is 90, math is 150, biology is 45 from the above. Now I want the value of C. So the value of C will be, let's proceed. So we have that, subtract. We find that now the value of C at that contact level will just be 75 degrees. Okay, now we have everything in terms of degrees, but remember they want a bar graph. They want a bar graph. So if you have that, then what are we going to consider? We have it in degrees. Now we must convert them from degrees into number of students. But the clue was like this. In the question they said the teacher provided one additional clue: 60 students were enrolled in biology. Okay, so in fact, for us, as far as our question is concerned, for us we shall say that 60 students are enrolled in the class. You remove this word biology, because biology will call for a lot of things. So enrolled in the class. So please, you call off this word here, biology, you call it off, such that we can move on. Because if it says for biology, it means that we shall need to calculate for total number of students altogether. Okay, and as per the guide I provided, it works when this it's not only in biology, but the class has 60 students. We shall take it as that. And now let's go there. So if the class has 60 students, then let's see. Let's calculate for math, which is M. Math is 90 over 360, rather than 50 over 360, times the total, which is 60 students. That will give us 25 students. So we get the degrees over total degrees in the circle times the number of students. We'll do the same for physics. We'll do the same for chemistry. And do the same for biology. So in our final, now have that on our bar graph. Please, I've changed here. I want us to be clear. In this question, they said that 60 students enrolled in biology, and as per the guide I provided when 60 students are there in total, and that's how the guide can be valid. But if it is 60 students are enrolled in biology, then we need to see the total number of students. That also works, but let's take it as that. Okay. So now let's can see. So now next, you want to see how we can draw this on a bar graph. You want to see how we can draw this on a bar graph. How? Now, if you have our bar graph in this format, so our bar graph shall have that. Down here we shall have what? Okay. Okay, we shall have subjects here. Of course, you all know by bar graphs. Subjects. Then here we shall have, okay, I think students up the side. Then a bar graph appears like this. They shouldn't be joined. More like a histogram, but shouldn't be joined. That's how a bar graph appears. Now we shall be planting these values in there. Let's can see. First of all, let's demarcate very fast. We are demarcating. We are demarcating. Put the numbers. Now that's the scale I've chosen. You can also think about another scale. That's the scale I've chosen. I've chosen a scale of 5. I've chosen a scale of 5, please. Hope we are together there. Now first, you want to go and plot. Remember, when you try to rewind back, as far as mathematics is concerned, we have 60 students. Mathematics is concerned, we have 60 students. So that means that the 60 students will come like this. Start from here. You leave space, by the way. Start from here, go up to 60. Where is 60? 60. It is this side. Not 60 students, but 25 students, by the way, as far as math is concerned. Now 25 is here, like this. So, draw a line down there, join to this, to there. That's mathematics. Next is physics with 15, and 15 is here, like this. You always skip a bar, equal bars. So please, I've skipped this and I've drawn there. The next one is 13. So 13 is somewhere here. Draw there like that. Then finally, skip it. You skip, please. We are skipping, you think. Then last we have 7 students. 7 students will be around here. And that's game down. So that's our bar graph will appear. Let's go there and see the real science. Okay. let's see. Now first we go up 25. That is of course reminder. You see that here in mathematics we have 25, so that's what you are plotting. That's 25. You skip a space here, then you draw in front. That's our 25. Now next we have 15. Now that's our math. 15. You see that I've gone up to 15. Close it there like that. Now next is 13. So this one here is okay, physics. Next is 13, up somewhere there. You must be very keen at studying your scale. Okay, and lastly we have 7. That's chemistry. Last we'll have 7. And finally there. And now that marks the end of what they needed. They needed you to draw a bar graph, and that's how it should appear. So it means that in this school the students perform mathematics better than any other subject. Wow, that's kinda great and interesting. Okay, let's proceed. So that's our bio. The scales must be, rather the axes must be labeled, and you also need a graph. That's the title, a bar graph showing subjects of offered, a subjects offered by students. That's our title. Then we also need the labeling the axes. Vertical axis have students, and the horizontal axis have subjects. That's how your graph must appear, a bar graph. Let's move next. So finally this brings us straight away to okay, activity of integration 10, and that is specifically about reflections. So about reflection, they're saying a man owns a house located on the side of a road which follows a line y is equal to x. The corners of the house are scaled in meters at points that. Now I have coordinate A, B, C, D. The government plans to extend the road which will pass through the area where his house currently stands. To solve this, the road engineer proposes demolishing the house, rebuilding it on opposite side of the road, maintaining the same size and shape. The engineer suggests using the road as the line of symmetry, as a line of reflection. Take note, the road as a line of reflection. Remember, this was our road, that is a line of reflection. Now if you covered reflections, please, these ones here, they can as well be done in senior 1, but in your transformations in book 3 can as well repeated. They can repeat this topic of reflections. So reflection to find, so this one is our reflection, more like our mirror. I'll put that. To find a new location of the house, but they need assistance in determining the exact coordinates for the new house. Okay, help the engineer by finding the new coordinates for the house after reflecting each of the 4 corners. So we are simply going to do reflection. And how do you do that? Begin by plotting this line y is equal to ax. It will appear like that. Then you have the coordinates. For example, A. This one will act like a mirror. And now this A must be got this side as A prime. The image is always A prime. Now let's see how can that be done. Let's go there. So first of all, we shall pick it from the graph. But before we move, please look. We have our equation is y is equal to x, and so it must begin with. Now y equal to x means that if these are equal, it means that even the coordinates, if y is equal to x, if this one is 0, x is 0, y will be 0. If x is 10, y will be 10. If x is 20, y will be 20. Like that. That's what this equation means, the simple one. So it's very easy to generate equations, like the coordinates which are going to plot. So this one is going to act as our mirror line. We call it a mirror line, and we begin by plotting that. So trying to label the axes, simple terms. Labeling the axes. Labeling the axes. So the scale I've chosen, you see that is big. Reason, the coordinates I'm having here are also big. Then 10 is 30s, 40s, 60s. That's why I'm using that kind of scale. So next, to begin with, let's start off with the plotting. So you plot the coordinates. Please, you are plotting these very coordinates here. So you also try plotting and we go together. So you are plotting, okay, here, coordinate A is 10, 30. And there we are, we have it here. In fact, it is 1030. That means that, no, that's not a coordinate A. I'm first of all plotting. Now what you are doing here in simple terms is, you're plotting these coordinates here for this line y is equal to x, which will be our mirror line. And first you have plotted the coordinate. Okay. Now if they are equal, to mean that even at negative 20, you can have a coordinate there. Even at 20 and 20, you have a coordinate there. So that's what I'm using the logic here. They must be equal, x value and y value, in order to come up with that line. So let's see what next. So you have drawn that line, label it, that's our line, y is equal to x. Now this line here is going to act like a mirror. It's going to act like a mirror. You all have used the mirrors in the saloon. This one's going to act as a mirror. Allow me to draw that there. It's going to act like a mirror. So in the so doing, what are you going to do? Now let's start plotting the coordinates. Plotting coordinate A. Coordinate A is 1030, and have it there, 1030. Coordinate B is 4060. We have it there. And coordinate C, we have it there. And coordinate D, we have it there. The next is joining the points. Next is joining the points. Next is joining the points. Okay, having done that, then what do you expect? After doing that, now we must reflect. But how is the reflection done? Please allow me to remove this one of the mirror. Good enough, you have known that is a mirror. Now when you put here mirror in these letters here, it means that, let me first bring this. It means that you have your A prime somewhere there. You have your D somewhere there. You have your B somewhere there. And you have your C somewhere there. Then you later join them like this down. They will have been reflected by the mirror. So let me erase that off, and we got the real work. So having done that, then what do you need to come up with this? You now need to get your a set square. Please, a set square looks like this. Forget a little bit. Maybe you can practically do it. A set square, you come and get your set square and place its edge. Place a set square on here like this, and make sure that this side of 90 degrees of a set square, in fact, let me remove this. I want to get you on this a little bit. So a set square is like this. So let's continue, I think. So you come and put your set square here. Come and put your set square here. A set square, this is your line. You now come and put your set square like this. So that side of 90 degrees is on that line. Now you slide that set square. Maybe your set square is at this level, in that order, whereby the 90 degrees is in this axis. So you move until in this point here. This line is in a straight line with the A. So therefore, you move a set square until when this A is at this level here like this, and the set square is this side. Okay, like that. Then with that, you draw using a ruler and make a line there like that. After making a line, come and measure the distance from here up to that line. Then that distance, without changing it, you come and measure it on this, and you put your marking. That is where you have your A prime. You do the same, slide the set square up to when the set square is at this level, whereby the other 90 axis is in line with B, but together, lining with the line with the mirror line together. Also there, draw a line. Then after that, you come and measure distance from here up to here, and make a marking. That will be your B prime. You do the same for this set square here like this. 90 must be in line with that. Then also draw a line. Measure distance from here up to here, and put your marking there. So those are the steps you're going to go through. Please. Okay. So let's see. That's what I've talked about. And that will be our A prime. That's what I've talked about. That will be our B prime. That's C prime. That's what I talked about. That's our C prime. Our D prime. Okay, A prime, B prime, C prime, D prime. You now join the points like that, and there. Okay, so but even here you can use the compass, please. You can use the compass here, whereby if you are using a compass, you come and put a compass pointer here, then you make an arc, and also you put a compass point at, if you want to draw the images of A prime, put a compass point at A prime, make an arc, make an arc. After that, stand at this axis, make another arc this side, stand here, make another arc. Then draw a straight line to pass through A, and into this axis here. Then get a ruler and measure, get a ruler and measure, get a ruler and measure, measure from here up to there, that distance using a ruler or a compass. Come and put on this middle line and measure on, put your marking on that line you have drawn. That be your A prime. The same way, if you want to measure the one at C, stand at C, adjust your compass, make an arc, make an arc. Stand at one of the arcs, make an arc in front, stand here, make another arc, draw a line to pass through there. Now measure distance from here up to this, and on the same line measure it from there up to there. Put there your C prime. That's how simple we can go about that. I hope that explanation makes some difference. It is kinda hard to bring a compass on this software here. So that's what we have finally as our image. Now here they want the coordinates of the image or the house. So the coordinates, you have them here. The coordinates for the house after reflection are, so A prime is 10, 30, B prime is 60, 40, C prime is 80, 20, and D prime is 50, negative 10. As simple as that. Let's now move to the next number. They're saying activity of integration, topic 11, that is the inclusion of lines. Okay, they're saying a tourist is planning to visit a game park where the entry fee is Uganda X 60,000, and for every day spent inside the park, an additional fee of 30,000 per day is charged. Now take note, this 60,000 is the entry fee. It doesn't change, it is ever like that. But again, every day this person spends 30,000 per day. Now per day, if you are spending 30,000 per day, it means that it keeps on changing. Because when you look at inclusion of a line, y is equal to mx plus c. This c is a constant, doesn't change. This x changes, the y changes, and the gradient may also not change. So c and m, this one may not necessarily change, they're ever the same. The x and y will change. Okay, let's continue. Okay, so they're saying the tourist wants to know the cost of staying for only 4 days, and also plans to spend a total of Uganda shilling 520,000, but is unsure of, okay, he's unsure of how many days he can afford to stay. He wants to develop a mathematical relationship between the number of days spent in the park, so the word number of days in the park, and the total cost. So here you're going to look at number of days and the cost, total cost, to help him predict future costs. Okay, help the tourist by deriving the formula. Deriving means to find, generate. By generating the formula to calculate the total cost of 4 days, and determining how many days he can afford to stay with the total budget of Uganda X 420,000. So let's kind of step in for that. First of all, we must generate an equation of a line. An equation of a line must have values of x and y. Let's go there. So you have that, let x be the number of days and let y be the total cost. So you have agreed on that. Next, let's see. So our C, a constant which doesn't change, is 60,000. Please have explained this. This 60,000 here, I told you it doesn't change. The entry fee for a bar, it will be fixed, doesn't change. Regardless, you must pay 60,000. So let's go there and see. So it is constant, that's why you're letting it to be a C. The next, our gradient is 30,000, also not changing. Now why our gradient is because the gradient with it can go up or down. Now I want you to see here, this is something I want us to reason about a gradient. I want us to reason on this. So about this one here, Uganda shillings 30,000 per day is charged. So it means that someone can decide not to go. So if you're going every day, now these are types of gradients. If you're going every day, it will go up. If you decide not to go, if you decide to go and not spend, it will go down. That's the type of gradient. Then if you decide to be there, but without spending, it will remain constant. These are types of gradients. So why you're using 30,000? Because someone can decide to go, someone can decide to go and spend, that's this graph. Someone can decide to go there and fails to spend, that's that graph. Then someone, okay, here, spends less. Then here, doesn't spend anything, where the gradient is not changing. So that's why I'm calling this one to be our gradient. That's now going to see. Next part. So now using the general equation of a line, y is equal to mx plus c. What do you expect? Let's substitute. Since we have our m and we have our c, let's substitute. So we realize that here we have our C is here, we have put it there as that. Our 30,000 is there and we have put it here as M. Now the X are ones changing. They're changing a Y and X, of which X is the number of days and Y is the total cost. So let's see. So if you have any question which deals with the two things changing, then you can think about what? You can think about equation of a line. Let's move on. So now cost of staying for 4 days is that. Cost of staying for 4 days is that. Because now here they asked, since you have now the equation of a line, this is our equation of a line. Why this is not talking out? This is our equation of a line. This one is our equation of a line. So we want to use it. Remember, X is the number of days, and Y is the amount of money spent. So they're saying that the cost of staying for 4 days, this came in this part here. So they're saying that he wants to develop a mathematical relationship between the number of days spent in the park and total cost. Okay, help the tourist by deriving the formula to calculate the total cost of 4 days. That's what you're doing. And that total cost will be total cost will be 180,000. If you try to compute, we are substituting here, please. We substituted here. It is 30,000 times x, so 30,000 times 4. That gave us 120. Then plus 60,000, that gives us 180. You must now conclude and say the tourist needs 180,000 shillings for 4 days. So we have seen that. And I guess you're seeing how important the equations are. Okay. So next now we must see how many days can he afford with 420,000. Of course, if you remember, here they said something. How much? Help the tourist by deriving a formula to calculate the total cost of 4 days and determining how many days he can afford to stay with the total of budget of Uganda X 420. So how many days are in 420,000? Let's go and see. Still, we are going to use the equation of. Okay, get this back. We're going to use the equation of a line to get that done. Just getting there. So, how many days can he afford with shillings 410,000? It is when y is equal to, please, this should be 420. Sorry. You must add here another 0. Add another 0. So from y is equal to 30,000 x plus 60, substitute now the y, you shall put it here. So in substitute you get, shall get that. And now when you solve for the value of x, shall get that. And our value of x will be 18. So therefore, he will spend 18 days out of that amount of money. So therefore, you say the tourist will be in the park for 18 days on a budget of 120,000. Like that, as simple as that. And that pushes us to activity 12. Let's go there and see. Now they're saying, oh, why is it like this? Start with the saying activity of integration for topic 12, that is algebra 1, theme, patterns of algebra. Let's go there and see. So they're saying, now in algebra 1, we look at how we can find some of the unknowns. In algebra 1, that's why we get to know how we can multiply, deal with the operations like the positives and negatives. So you imply a positive and a positive, must get a positive, things like that. And more are how to find the ages of different people after a given period of time. Of course, I've been doing that right from primary, and I guess this will just be a walk over. So they're saying Jimmy and Peter do not know their exact ages. Jimmy and Peter do not know their exact ages. However, they have the following information. Jimmy is the older brother, and in 2002, Jimmy was 5 years older than Peter. Okay. In 2005, Jimmy was twice as old as Peter. Alright, they are seeking your help to find their exact ages. Task: use the information provided to find the exact ages of Jimmy and Peter. So this is a bit simple. Let's get there. So first, let's get their tables. So that is Jimmy and Peter. So now let's go back to the question. I want us to notice something. So here they're saying in the question like this. They're saying that Jimmy, remove this. They're saying that Jimmy and Peter do not know the exact ages. However, they have the following information. Jimmy is older than the brother. Jimmy is older than the brother. Now, in these numbers of ages, please, what you do, you look at the order, how they've mentioned. Now here I have Jimmy, and finally I have what? Okay, sorry. I have brother. And the brother to Jimmy is Peter. So therefore, the last person to be mentioned, you will let this second person here to be X. This last person here, you let him to be X. My ink pen is not writing well, but you take this one, you let, because you have Juma is older than, then they bring brother. The last one, let it to be X. Then the changes can happen the other side. Like, say for example, let's go there and see. So now in 2002, what should we see in 2002? In 2002, what happened was, in 2002, Jimmy was 5 years older than Peter. But remember, we have said that Peter will be X. So in that older than, it means that as Peter is X, Jimmy will be X plus 5, which is older, is 5 years older than Peter. So Peter is X, so there will be X plus 5. Let's go there and see. So Jimmy will be X plus 5, and Peter will be X, as simple as that. Now let's move on. How about in 2005? Now in 2005, what happened here? Okay, in 2005, Jimmy was twice as old as Peter. In 2005, Jimmy was twice as old as Peter. Was twice as old as Peter. Okay, now there is something you must notice here before we go any further. As you're moving, in fact, let me go back here. So as you're moving from 2005 here, look, what's the range of years from 2005 to 2002, from 2002 to 2005? Now from 2002 count, there are 4 years there. Though when you subtract directly, you see that there are 3, but there are 4. Count. Let's start with 2002. Let's go 2003. Let's go 2004 and 2005. I think when you count here, there will be 1, 2, 3, and 4. Please count well. Start with 2002, that's 1 year. 2003, that's the second year. 2004, that is the third year. 2005, that's the fourth year. It means that from 2002 up to 2005, there is a period of 4 years which has moved by. And as from 2005 to 2002 to 2005, that period of 4 years goes for, there's an increase in Jimmy's age and an increase in Peter's age. So let's go on. So as that goes on, we shall have that x plus 5 but plus 4. Remember his age in 2002 was x plus 5. Now that plus 4 is because of that time travel after some 4 years. Be ready, be steady on how we count that. Okay, now having done that, now they're saying here in the statement that please note that the plus 4 picked it from the range from between 2002 and 2005. They are 4 years. We read them on paper starting with 2002 up to 2005 and you count the years that are 4. So Jimmy was twice as old as Peter. Now this statement, Jimmy was twice as old as Peter. Let's go and analyze it. It will give us the answer. Okay. So we are trying to simplify those ones half up. So simplifying what you have up there. When you simplify up, you get this. When you simplify that, you get that. So let's see. So now we are saying that Jimmy. We are saying that Jimmy. Okay, we are saying that Jimmy is twice as old as Peter. So now that means that statement means that Jimmy's age is equal to 2 times Peter's age. That's what that statement means. Please take note, this twice here is means equal sign, twice means times Peter's age. Now, but Peter's age or Jimmy's age is here. Jimmy's age is here. Look, Jimmy's age is here as x plus 9. Peter's age is x plus 4. So just come and substitute in and get the answer. So you try to multiply there. Shall get that. So realize that here shall have this. Please, my ink pen is a bit slow, that's why we are not moving on the same pace. 2 times x shall get 2x, 2 times 4 you get 8. Next is collecting right terms and getting a value of x. So x is equal to 1. Therefore, if x is equal to 1, then what must we see? Next. Now if x is equal to 1, let's go and say in 2005. Remember the one their present age and our present year here is 2005 after 4 years. So you get from Jimmy's part, which is x plus 9, but x is 1. So that will be 1 plus 9, and that will finally give us 10 years for Jimmy. Then on the side of Peter, his age is x plus 4, and it will be 1 plus 4. Of course, the value of x is 1. It will give us 5 years. So that's how old they are. Jimmy is 10 and the other one is 5. Let's see. Now we can conclude and say that Jimmy is 10 years while Peter is 5 years. And that was activity of integration 12. Let's now go to activity of integration 13. We're about to finish. Remember, they are only 14 topics. They are. Okay, start away. Now this is business mathematics. However, though, this can be repeated in book 3. More work is there, but we also have it in book 1. Let's step in for it. They're saying a company sales agent is selling phones priced. Let me hope this ink pen will work well this time round. I don't know what has happened to this ink pen.